right? We want the computer to help us design for a target property. So given my desired property, what is the material that fulfills it, right? So it's an inverse problem. It might not be bijective, right? There are big challenges to this, but in truth, what we're trying to solve is this, right? It's condition on the property I want. What is the arrangement of matter that will give me that, if that's even possible? And this relates, this paper keeps getting older and older. It's 2018 now, and it still looks amazing. This relates to generative tasks, right? This borrows and is inspired and parallel by generative models in machine learning, where what we're trying to do is to sample members of a complex distribution, right? Only the distribution this time is not the distribution of celebrity faces. Now we want to sample from the distribution of molecules to find the molecule that is the deepest, more color pure blue, to make the blue pixel in your TV, right? That's the nature of the task. And the architecture that do this and look like they're good at this are generative models. So back in 2015, 2016, we started playing around with the variational autoencoders, and that was one of the first examples where one could do this, right? We take a molecule, we encode it as a vector, so we get this graph to vector, right? And now it's a continuous vector. We can numerically modify it, right? We can do gradient descent over property prediction. We can sample from the distribution at random and learn to decode all of these molecules back into the input, right? So we set up a variational autoencoder architecture that learns to reconstruct an input into its own image at the output, and in the meantime learns this embedding, this continuous embedding, where every latent point corresponds to a molecule, not just the ones we've seen at train, but it learns to generalize and produce new molecules that are related, right? They come from the same distribution as the training data. They're related to the training data. They have sort of the same distribution of properties, but they're new, right? They haven't been made yet.